Hi, my name is Jared. This recording is for the University of Denver. The class is Business of the Built Environment. Today we're going to be looking at FAR and site coverage and how the two affect density within real estate development.
So FAR is described as the floor area ratio, and it's the ratio of the built area or the building size to the lot that it is sitting on, or the lot size. To reach the FAR, you take the buildable site and the building size and divide it by the lot area, and that would give you the FAR. Or working backwards, you can take the size of the lot that you have and multiply it times the FAR, and that'll help you determine the overall building size that you can build on this lot. So I'm going to demonstrate some FAR ratios and illustrate how different FARs translate into actual buildings. So if we begin with the overall lot size, if this is the lot that you have to develop and you're dealing with a FAR of 1.0, then that would basically mean that the entire site would be covered by a building. So that would represent an FAR of 1.0. Looking at the same lot size, so we have the same overall lot size, but if we now do a building that only covers 1/9 of the overall lot, that would mean that this building would be 9 floors tall, and that would still translate to an FAR of 1.0. So you can see, just to begin with, how two different FARs look very different on the same size lot. Looking at some different FAR ratios, we have the same building site, but this time we're going to look at an FAR of 0.5. So that would mean that half of the lot's overall area would be covered by a building. So this would be one way of translating a 0.5 FAR onto a site. Another way of looking at the same site would be if you only covered 25% of that site with a building, then that building would need to be 2 stories tall to give you the same FAR of 0.5. So now we can see what two different coverages look like with an FAR of 0.5. Continuing on to some other FAR numbers, an FAR of 2.0, if we go back to our original diagram of the site with 100% building coverage, at a FAR of 2.0, then that building would need to be 2 stories tall to reach the FAR of 2.0. On the same size site, from our previous diagram where we covered only 1/9 of the site, now we're covering 2/9 of the site with the same 9-story building. And that would translate into an FAR of 2.0. A very simple diagram of an FAR of 4.0 would be to take the entire site and cover it with a 4-story building, which would give you an FAR of 4.0. So when we zoom back and take an overall view at this, you can start to see how different FARs translate onto the building sites. The next thing that we're going to look at is site coverage. and that's the relationship between the ground floor area of an enclosed building and the total area of the lot. The ground floor area is important because it doesn't take into account any of the upper floors. It only looks at the ground floor. So if you take the lot size and divide it by the building footprint, that would give you the amount of coverage. Or conversely, if you took the lot size and multiplied it by the allowable coverage, that would give you the building footprint that you could develop. So again, let's look at the same simple lot diagrams. If we took this lot and applied a 100% coverage ratio, then that's pretty simple that the entire lot would be covered by a building at 100%. Looking back at our previous building that covered 1/9 of the site, that 9-story tall building would translate to 11% coverage. Looking at the 50% coverage, then half of the overall site would be occupied by the building footprint. And then the same goes for 25% coverage, where 25% of the site would be occupied by a building. So again, we're not really dealing with we're not looking at FAR here or the total volume of the building, but we're only looking at the footprint of the building at coverage ratios. So that would be 25%, 50%, 11%, and 100%. So now let's take a look at how these two relate to one another and can affect building density and development square footage. For this last diagram, we're going to look at FAR and coverage ratios and show how different site coverages and FAR relate to one another as they both increase going across the page. So at the top of the page, you can see we're going to be starting with 25% coverage, moving to 50% coverage, 75% coverage, and then increasing FARs that increase from 1.0, 2.0, and 3.0. So looking at the first building, this building footprint is covering 25% of the site. So at a FAR of 1.0, this would need to have 4 floors of the building to have 25% coverage at a FAR of 1.0. At 50% coverage, then you would need to have 2 floors of a building that's covering 50% of the site to reach an FAR, again, of 1.0. At 75%, we start with a footprint that occupies 75% of the site. And then you would need to have 2 floors of one of the buildings to give you an FAR of 1.0. So looking across the first row of this chart, we now have 3 buildings at very different coverage ratios, but all of these represent an FAR of 1.0. Moving down the page, we're now going to look at the same 25% coverage, but with an FAR of 2.0, you now need 8 floors of the same building to represent an FAR of 2.0. With the 50% coverage building, the coverage remains the same. The site is still only occupied by 50% of the building footprint, but at an FAR of 2.0, you need 4 floors of that building to give you the FAR of 2.0. And then looking at the 75% coverage, you would need 3 floors of the back 2 buildings and then 2 floors of the front 2 buildings. So you can start to see now we're starting to see the impact of FAR and coverage ratios. Moving down to the last ratio, we're at 3.0. So this building now grows to 12 floors tall with the same 25% coverage of the overall building site. Realize it would be helpful to draw those in. Moving to the next one, at the 50% coverage building, to reach the FAR of 3.0, again, those floors need to increase to 6 floors. And then looking at the last one, the 75% coverage building, you need 4 floors of each of these 3 buildings to reach the FAR of 3.0. So now when we step back and look at this diagram again, we can see how the increasing coverage and the increasing FAR equate to a much more building mass, both in the amount of footprint that covers the site, but also the volume of the building and the total developable square footage.